In this video for the Section 8.3 activity, we're going to introduce the idea of conditional probability. We're going to look at this data, which we've seen before, where we have enrollments in a mathematics class, and we are identifying whether the student is a sophomore or a junior, and whether the student is in the College of Arts and Sciences or the College of Business. So our first question says, if we randomly select a sophomore, what is the probability that they are in the College of Business? So if we randomly select a sophomore, that means that we know already that the student is a sophomore. We are restricting our data set to only the students who are sophomores, only those 85 students. So when I look at my table, I see that I have 66 sophomores in the College of Business. Out of a total of 85 sophomores. So to find the probability that a randomly selected student would be in the College of Business, I would divide 66 divided by 85. And if you do that on your calculator, you will get 0.7765 if I round to 4 digits after the decimal point. So just like with previous problems in the homework, sometimes they will ask you to enter a fraction, other times they may ask you to enter a decimal. So question 2 says, if we randomly select a student from the College of Arts and Sciences, what is the probability that the student is a junior? So now we are looking at only students who are in the College of Arts and Sciences. So I'm going to just be looking at this row here. And I see that there are 33 total students from the College of Arts and Sciences, and 14 of them are juniors. So we have 14 juniors in the College of Arts and Sciences out of a total of 33 students in the College of Arts and Sciences. So my answer is going to be 14 divided by 33, which as a decimal is about 0.424. Again, pay attention to how the problem wants you to enter your answer, whether it's a fraction or a decimal, and where they want you to round. So these are called conditional probabilities. Conditional probabilities are finding the probability of an event given that another event has occurred. And we see this word given in these problems a lot. So we have this notation for conditional probabilities. It's P, which stands for probability, and then in parentheses we have A, something, and then we have a vertical line that separates it from B, which is something else. So this is the probability of event A occurring, given that event B has already occurred. And so we say the probability of A given B. So for example, for question 1, our question was, if we randomly select a sophomore, what is the probability that they are in the College of Business? So we know that the student is a sophomore because we know that we're only selecting from the students who are sophomores. So that is our event that has already occurred. So that comes after the vertical line. The student is a sophomore is our B in this situation. And the A is the student is in the College of Business. So that's the probability that we're trying to find. So a lot of times the questions are written in the opposite way. Of course, questions could be written differently, but a lot of times you'll see the thing that's being asked, which is going to come first in the probability statement, and then the thing that we already know is usually given first, and then that is going to come in the second part of the probability statement. So let's fill in the blanks for the situation in question 2. Question 2 says, if we randomly select a student from the College of Arts and Sciences. So that's going to be our given part of the statement. The student is from the College of Arts and Sciences. And then our question part is, what is the probability that the student is a junior? So that's going to be our first part of our probability statement. The student is a junior. So we're asking for the probability that a student is a junior given that the student is from the College of Arts and Sciences, because that's the part that we're selecting from. So question 4 says to find the probability that the student is in the College of Arts and Sciences given that the student is a junior. So we're going to start with the second part, the student is a junior, and figure out how that restricts our table here. So we are looking at only the juniors. So I'm going to take the green highlighting off here and focus on just the column of students that are juniors. Whoops, I didn't want to highlight the whole table. Just the junior column. So I have 35 total juniors, and I want to find the probability that a student is in the College of Arts and Sciences. So out of my 35 total juniors, 14 are in the College of Arts and Sciences. So we have 14 juniors in the College of Arts and Sciences. Out of 35 total juniors. So my probability is 14 divided by 35. And if I do that on a calculator, I should get 0.4. Question 5 is find the probability that the student is a junior given that the student is in the College of Arts and Sciences. So we're now looking at just the students who are in the College of Arts and Sciences. This is one that we've actually already found. 33 total students, and 14 of them are juniors. So 14 juniors in the College of Arts and Sciences out of 33 total students in the College of Arts and Sciences. So 14 divided by 33, which we found earlier to be 0.424. And finally, we want to know if we can switch around these two parts of the statement. So is probability of A given B equal to probability of B given A? And if we look at our results from question 4 and question 5, we see that that's exactly what we're doing here. We are switching around the two parts of the statement. And we can see that we do not get the same answer. We have 14 out of 35 for question 4 and 14 out of 33 for question 5. So the answer to this is no. You cannot switch around the two parts of the statement. The answers to questions 4 and 5 are not the same. So we have found a counterexample here that shows that probability of A given B is not equal to probability of B given A.